I was going to start streaming earlier today, but I was watching a bunch of videos and there's a bunch of stuff to learn. So I'm trying to make a Bezier curve on 3D on Godot. And initially I was trying to do with a Blender, like transfer the curve from Blender to Godot. But now I think I'm going to try to build it just based on what I think. I'm not really sure. I don't have the full picture yet, but I'm thinking about trying to get the equation for the Bezier curve in 3D, then just get the shape, the cylinder shape that Godot already has, or one of the variations. It could be the tube trail mesh shape or something like that, and then just try to change that shape so that I have the vertices over the Bezier curve. But the biggest problem with this is the rotation of the points, because I think that if you just draw a circle and you do some like you get the Bezier curve equation and then you just put the points, and then for each point you just draw a bunch of circles. I don't think it's gonna work, but I'm just gonna try stuff and see what happens. And I'm probably gonna go back and forth between this approach and the Blender approach. So I took a bunch of notes here as well on these keywords that I found that are interesting, and I'm watching a bunch of videos. So this is basically all the keywords that I have so far. I'm probably gonna have to spend a bunch of time studying as well. But today, what I'm gonna do now is just to try to get the points from the meshes that they have already, and I'm creating another mesh, a custom mesh on Godot, and I'm going to already have the function there. I'm gonna put the vertices on that function to see what shapes they produce, and I'm gonna test some stuff and just play around and see what happens. But there's a bunch of I might go back to. So the reason why I stopped trying to convert from Blender so far is because the way that they do the functions is very different. Is because they're using C pointers instead of using the data structures that I have there, which are the classes that Godot uses to manipulate matrices and stuff like that. So I found that it was very annoying to convert everything. I was converting the functions to try to test, and then there's a bunch of times that they use the quaternions, and I feel like I didn't understand very well. Like I wanted to try an approach that allows me to have a clear picture from the beginning of what is going on when you build the curve. And also I realized that I had the wrong idea of Bezier curves as I was doing this previous live streams, because the way that it works is that the points are, let's say, I think on the Bezier curve the points are inside of the curve, but you have more control points that basically create like shapes that have hard edges, let's say. They don't have, like, they're not curves, and then from those shapes, by linear interpolating the points outside, you create a curve. So on Blender they create a Bezier curve with 3 points inside of the curve, but actually you need 6 points in the beginning, and those 6 points are the things that create the shape that is going to be used for calculating the path of the point that actually creates the curve. Then from that path they derive a bunch of different points by doing iteration, and that's what the bev points are. Then after that they do like the calculation to do the circle from the point, I think, and along the line they use quaternions, I think, to get the rotation, and they do it, I think that they do it based on the differences in points along the line, but I don't understand very well how it works yet. So I'm gonna start doing Enki because I didn't do it today, and then I'm going to spend time on Godot. I think the first thing that I'm gonna do is just try to add the properties of the mesh that I have there so that I can manipulate from the editor. So I went back to doing from PowerShell. There's a couple of commands that I forgot. This one, I think I remembered just yesterday. I think it's Invoke commands, computer name. But a lot of them I still remember. It's a good sign. Yeah. Parameter, it's like this. Parameter, mandatory goes through. Oh, I fucked it up there. Actually, just the spaces, but the thing is correct. Service. I'm just gonna do a couple of them. I'm just gonna do not much at all. You select string this one. And path, file path, raw. Oh, get contents. Initially, I was thinking about the way that I'm doing this. I'm not really taking this like very seriously. It's just more additional stuff that I'm doing now, and I'm just being trying to keep like at least there are a lot of days that I'm focusing on a lot of other stuff, so I just do like 5 or 10 reps or something like that. It's probably gonna be what I'm gonna do today. But initially I was doing 3,000. I thought about doing 3,000 for each one and then going back the cycle. But now I think that's probably a lot better to do just 1,000 or even 500 for each one and then move on to the next one and then do the iteration like this. Because it felt redundant when I was doing this the first time. But now there's a couple of commands that I still don't remember because there's been a lot of time since I didn't do it for partial. So I think this is import module or something like that. And this one I do remember it's something like this. But I don't remember if it is import module here or something else. And I think that there is something else after the library. It's farce. Might be like this. Yeah. I don't remember if it's the curly braces or if it's the other thing. I think it is like this. Yeah. So I'm gonna do just these ones. Just 9. So now I have to remember the stuff that I was doing here. Yeah, so I figured out last time, so the way that I was doing this was putting the notification on the graph 3D because I was testing some stuff. So I was calling the function here on the notification process event on the graph 3D to generate the mesh. So graph 3D is a class that I have that I'm gonna add nodes and edges, which are the other classes that I'm creating to create a graph in 3D on Godot. And so basically everything that inherits from node on Godot, you can declare this notification function, and you can, it's basically the same thing that happens on GDScript, where you can set up, depending on what kind of, what part of the cycle it is, you can call some different functions here. So I think that for edges and spheres, probably it makes sense to put on the notification process part of the cycle or notification process physics. So the idea is to, but now I think I'm gonna change this idea, but initially I was thinking about updating the values of the position of the mesh and updating the mesh itself each time on the rendering cycle and the notification process, and it wasn't working the first time. And then I figured out that the reason why it wasn't working is because you have to explicitly set for the class if you want the node to be called on the whenever there's a notification event. For the other ones, you don't need to set, but if you want to know the node should be processed, you need to put this stuff here, which is just set process equals true. And if you do that, then it's gonna call this function here with the notification process as the argument here. So I transferred the function to the edge mesh itself, because I couldn't put the notification here because this one inherits from a mesh, or from primitive mesh, no, from array mesh. So this is a class that I created that inherits from array mesh, and an array mesh is a Godot class that allows you to build geometry from vertices. All the other classes do that as well, but they do it in a different way. I'm not 100% sure about the nuances, but basically all the primitive meshes that you have there, which are the standard options you have on Godot, is going to be meshes that inherit from primitive mesh, and then they create their geometry on this create mesh array function, which is basically, I think is an abstract virtual function declared on the primitive mesh class that all these other classes inherit from. And basically here you create the points, normals, tangents, and whatever. And this function here, for example, is for the torus mesh, and it creates the shape there based on the vertices that you build here. But for array meshes, you do it differently. And is what they recommend on the documentation is either array mesh or immediate mesh, or you can use surface tool as well. I think those are the main three options that you have if you want to create a custom geometry. The other option, which I'm probably gonna look into now as well, is to create a CSG polygon mesh, and then you create a path 3D or a curve 3D, and then you add that to the CSG polygon, and that makes it so that you create. I'm gonna test to see if that I can do that, but as far as I remember, it's not very clear on how to build like an actual curve. Usually, it only builds the polygon, and then it builds the polygon through the path. But I'm gonna look into that function to see if I can put the function on this class that I have here to change the vertices so that I can draw a 3D curve. So I'm gonna look into the way that they do the path 3D or curve 3D to see how they do the functions to calculate the points and stuff like that. But basically on array mesh, they recommend you to either you put on the class constructor, so it runs only one time when it's initialized, or you build every time on the iteration. And usually based on the tutorials, they do it on GDScript, but it's based on the events. So it's the same thing that I'm doing here. So graph edge 3D is a class that inherits from mesh instance 3D. Then I set the mesh for this class as the edge mesh, which is the other class that I created. And in this class here, I have the notification function, and then inside of the notification process, I call the build curve from the edge mesh, which is this function here. Well, not this function. It used to be here, and then I passed to this other place here. So it's basically this function. So this class inherits from primitive mesh. Oh no, from array mesh, and then these functions here are from the array mesh, and they're functions you need to use to set the vertices and stuff like that. So this is the main one, and you have to call this one so it cleans up every time, because this is going to be, this is being called every time on the cycle there, because I'm calling on the notification process here, which I'm going to change now. I'm going to do this on the constructor. And the reason why I'm going to change is because I think it makes more sense, because the way that the mesh is going to work is that, so basically array mesh is less performant, and the immediate mesh is less performant because it costs more to build the mesh each time if you have to build the vertices. So it makes more sense to build it only once and then update as least as you can, let's say, because it costs to update, obviously. So I think that now what I'm gonna do is just create the mesh in the beginning and then only change or only rebuild the geometry if there are changes on the positions of the nodes that the mesh is gonna connect, which is gonna happen on the graph, I think, the iteration of the graph. So I think it makes more sense to put here and not to update it each time here. Yeah, but the idea is basically the same. It's gonna call that function there. And the reason why I put this function here is because I was trying to convert to the Blender stuff on this folder here, and then I decided to create this other custom folder. And the idea that I have is just to try to create or figure out what are the most common operations. So the thing that I'm struggling the most with now is thinking about because I understand the transformations that you usually do on geometries on 3D. So usually the way that you do things is you multiply matrices, and then based on the multiplication of the matrices, you change the state of the geometry, because the matrix holds the state, which is the position of the points of the geometry. And each time you multiply that matrix by another matrix, you can implement either rotation or translation or other stuff like this. But for specific points, I'm not 100% sure how to go about doing this. So this is the kind of thing that I'm trying to clarify here. And I think that probably the best way to do this is to, like I said, get the functions from the other classes and then put on this function here, and then use this function as an experiment, let's say, and then try to figure out what are the most common operations. Because one of the annoying things that I was dealing with is both the thing about the pointer, that Blender uses pointers, and the way that they do everything is based on the pointer. So like they do pointer arithmetic, for example, and then they pass like the pointer on some functions, then they do pointer arithmetic inside of a for loop, for example, in order to get to the next point. But the way that I was thinking about it doing is more from vectors and stuff like that. So it's very confusing to move this stuff from Blender to here. But basically, this was one of the things that I was confused about. But I think that this function here from Blender is the first time that they create the Bezier curve on 3D. So it accepts the two different points, two different curves that they create. It's not two different curves, it's just the 6 points that make the curve that has 3 points in the beginning. So, and basically you can simplify a bunch of stuff if you don't care about the state. So this is what I was trying to do here. That's basically what they do in the beginning. They create one or 3 different points, and then they move the pointer, and then they create other 3 different points, and they store on a data structure inside of the NURB, which now I figure out that it stands for non-uniform rational B-spline. And then based on these points here, so these are basically the points that create the curve, because the curve is an interpolation of these points. And I think that this is what this function is doing. So it takes the two, let's say, curves in the beginning, and then based on them, it's going to do this calculation here, which is basically calculating the Bezier curve, as far as I understand now. But it's kind of confusing the way that they do it here. And also they pass the pointer as P, and they're going to change the pointer here. And this is like one of the parts that's kind of confusing. So I want to clarify, and there are other parts here as well. When it gets to the point where they're going to create a bevel and they're going to like give the depth to the curve. Another thing that I figure out is that when you see on the GUI, it's called depth, but on the source code it's called bevel radius. So the depth on the GUI is the bevel radius on the source code. And this is basically the main entry point function, I think, in the beginning that's gonna create the actual depth. So another confusing part is that, like, the way that I'm thinking about doing is you create the path of a curve, and then you select a couple of points on that curve, and then for each point you do a linear interpolation between, not necessarily linear interpolation, but you just get the distance from the points, and then you draw a circle for each one. So basically you iterate from the distance, and you draw a circle for each one. And the way that you draw a circle is just by drawing a bunch of triangles around the axis of the point. But the problem is, if you do like this, then it becomes a solid curve, and I think that's not very good. And the way that they do it, it seems to be like a hollow tube. So the thing that I'm kind of thinking about is, how does it work on the construction of the triangles that's they use to build the curve. That's the part that is more complicated to me, and I'm not 100% sure on how it works. Because obviously, if you get the shape of the cylinder, you can just get the outer circle and the inner circle, and then get the difference. But then I'm not 100% sure how it works in relationship to the triangles that you need to use in order to build the mesh. But basically here, as far as I understand, these bevel points here, these bevel points are the points that they're gonna. I think that those are the points inside of the curve, and then for each one of these bevel points, they create the circle around it. That actually creates the 3D curve. So basically, what I'm talking about is when you add Bezier curve here, and you put the depth here. Yeah, so this is what I'm talking about. So the part that I'm showing there, the first part is when you add the curve, is this part here up until here, where it just adds these 6 points, 6 different points, and then it does this calculation here in the beginning. I think in the beginning it doesn't. I don't remember if it does this one or not, but I do remember this 6 different points here. And then the second part is the one that's like this function here runs in the beginning. I did the flowchart as well after you add the depth here. And the depth here is just bevel radius on the source code, how they call but you can see that it's like hollow, the tube. So I imagine that the only thing that makes sense is that the way you do it is you create 2 different circles, and then in the gap between them, you create the surface around the circle. So you use like quads, which is just combination of 2 different triangles, to draw between the distance of the 2 different points on the radius outside. But to do that on the vertices is very difficult to think about because of the calculations of how do you select the points and stuff like that. This is what I'm trying to figure out now. So I assume that this is the other function that I was showing there. They're just going to take the 6 points and create the Bezier curve in 3D. So like for each for x, y, and z directions of both vectors, let's say, or both curves, which are just 3 points. So like they use 6 points to create the Bezier curve, but they divide them on 3. So like it's 3 from 1 point, let's say, this best triple, and this best triple here. And then for each one of these, they call this function for x, y, and z, which is the j here, based on the resolution there, which is the iteration. So I assume that this thing here creates the curve on 3D. And then after they do this, they calculate the rotation there. So I assume that what is happening, this is kind of the part that is difficult, but I think that they are storing all the points on one of these. I think it's probably this value here. Yeah. So, and then based on this value here, later on this function, they calculate the rotation of each point. And this is not their codes, it's just my code that I was trying to translate. But obviously, Godot uses a bunch of different data structures, just different in general, the way that they do it. So it's very annoying to convert because of the pointers and they usually use a pointer to a float pointer, just an array of floats, and then they do pointer arithmetic to go from one point to the other. But if you're using vectors on Godot, then obviously can't do that. And I think you can do it based on the floats as well, but it doesn't seem very good. And also, it feels overly complicated because they have to do a bunch of stuff to give more options and handle the state as well. So there's a bunch of extra stuff that they are calculating here. So that's the reason why I decided to go about it the way that I'm trying to go about it now. To get to that function there and then see. I want to manipulate the vertices and then see what happens on Godot on the editor, and then just do a bunch of experiments to clarify in my mind, like basically become better with the fundamentals of translating or creating meshes based on triangles. Because the most difficult part is to imagine the creation of the mesh uh, from using triangles. So that's the part that is kind of hard. Because if you could just do it the geometry, then it would be a lot easier. So I think I'm gonna forget about this stuff and try the other one. Then maybe I come back. And I don't think I'm gonna expose the points. So, but what I do want to do. So here. So I think on Godot, the way that you expose the stuff to change there, to customize on the editor, is by putting this add property here. So for each function of the class you create, you have to put this bind method. This allows you to see or allows the editor to know about the method. And I think for each method you want to expose on Godot, you need to put the add property, and you also need to create getters and setters for the class. And also you need to subscribe the class with GD class. You pass the name of the class in array mesh, and this allows the editor to understand what the class is about. So yeah, what I have to do is see what values. So basically I wanna, because I don't wanna have to rebuild, recompile, close, Godot, and open each time that I change something. I wanna be able to change from the editor as well. So I wanna see. I'm probably gonna create. Yeah, so I'm gonna create a bunch of functions here. I'm gonna create a function for each property that I have there. Setters and getters, and then adds properties, and then see if I can manipulate them. So it's probably better to do one first. It's probably gonna be the radios. There's a lot going on in my mind, so it's kind of hard to think about this stuff. I'm just gonna put 1 more hour, I think. I'm not really sure. Sometimes it's weird that it doesn't show the color right away. It might be just because of the VS Code. So yeah, let me think about this. I'm gonna see an example of this. So the first thing that I'm gonna do is just I'm gonna put one getter and setter for the radios, and then I'm gonna attach to see if I can change from the editor. Then if that works, I build for all the other properties there. And I think the easiest thing to do, so I was thinking about exposing the vertices as well, but because then I can make, probably eventually I'm gonna do this as well, put this as member variables of this class, instead of declaring them here. But you need to delete them each time, I think, after you add them to the array, if this is gonna run all the time. But I think every time that you update the mesh, you have to do this. But this is another thing that I'm gonna think about probably, but probably way later. Is obviously that you can cache the vertices and then just change the ones that actually need to change. So there are probably optimizations, but I think it's one of the things that is just more of a macro optimization. So it's not worth thinking about. And this code here creates a sphere. So I want to see, yeah, I'm going to try to make stuff here that depends on the variables there of the class, and then the variables that are part of the class, I'm going to manipulate from the editor and see what happens. And then from this code here, what I'm probably going to do, so what I'm thinking about trying to do is just the first approach that I thought about, and I think it's probably going to be interesting. So I think I can see a way to draw the curve. So there's actually a bunch of different approaches that I can take. One is to look into the CSG polygon and then the path 3D and study the way that they do it and try to translate those vertices to here. The other one is to study the cylinder or the tube trail mesh geometry that they have as well. And then just copy the code here and then change the code to implement the thing over the path of the Bezier curve. But the hardest part, I think, is creating the curvature in 3D. And the way that I was thinking about doing this is by, so, because it depends on how many points you get, but you can get the differences between the points, and then that way you have the vector. And the vector allows you to have a direction, I think, based on the previous. So basically, you're creating like a vector between different points along the curve. Then from the vector, you get the angle somehow. Then from the angle, you have to get the derivative. But the thing is kind of hard to think about. So I think the main thing is to have the Bezier curve equation first. So one of the ways that you can do it is just using this algorithm, which I think is very simple, but I mean, simple in theory, but I'm not really sure how to implement on C++. But from the video from Freya, this video here, she talks about just doing linear interpolation a bunch of times from the points. I forgot the name of the thing. Pretty sure it's here. Or maybe I didn't write. Maybe here. Maybe I have to. I forgot to write. Forgot to write, I think. Scastaglio something. But I can figure out that algorithm. Maybe just ask ChatGPT or just remember. And then find that algorithm somewhere and then put the algorithm there to create the, or change the algorithm from Blender to create the Bezier curve based on control points. Then once I have the algorithm that creates the curve based on the points, then I just implement a loop. So create the circle first, implement the loop, then for the curvature, get the differences. So I'm not really sure which way to go about doing this though, because yeah, that's the hard part. So you can take the derivative of the polynomial equation that creates the curve, and then based on the derivative, you can get the angles, I think. And then for each point, you get the angle, and then with the angle, you just use quaternions to rotate the point, or to rotate the circle. But I think that's... So first I'm gonna focus on trying to make at least something happen there. Think about this stuff. I'm not 100% sure which way to go about it. Sorry, because I think all of the ways are gonna take a lot of time. It's hard to calculate which one is less likely to take a bunch of time. So this is the name. So this is part of an object. I have to get one for floats. I'm gonna get the example for the float, just copy there. I forgot about this one. I think that's probably all we have to do. So I'm gonna compile and test. I think the trade-offs is that, like, if I try to do it based on the way that the Godot does it, I think it's much easier from the standpoint of the calculations of the transformations. Because to be honest, I think that is a little bit weird for me. I think it's because I was used to doing stuff from OpenGL and from using the TPP stuff that I had on the other project that I was doing. So like it feels kind of weird because the way that Godot does it is through transform 3D. So transform 3D is not 3D matrix, it's a 4D matrix, which is kind of confusing to me. So, and it's based on basis class, which is a 3x3 matrix, and one vector, which is the origin. So, and there's also the quaternion class as well. But on the quaternion class, they don't have functions for rotation. So obviously, I think not obviously, but I think that the reason why they did it like this is because when you're multiplying for continuous, it makes more sense to do it from the outside of the class, let's say, because continual rotation is just a multiplication from the points. So you multiply the points by you get a quaternion, then the points, then the inverse of the quaternion. So you do the multiplication like that, and that performs the rotation, I think. So for this kind of stuff, I think it's just easier to ask ChatGPT. Also, it does show here. Interesting. Let's put 20. But it doesn't change anything. I think it doesn't change anything because it's not updating the mesh. So probably to test here, I'm gonna have to. I guess what I can do is just call build surface there again, or build, yeah, build curve. So every time that I set, but I'm not really sure if that's. Yeah, I think that's probably better. So what I'm contemplating now is whether or not this makes sense here because I'm going to update from the graph anyway. So I'm gonna call build curve from the graph. That's the thing. Maybe I don't. Maybe it makes more sense to call build curve every time a property of the Layern 3D mesh changes. Actually, let me think. I think that makes sense because uh, what I'm going to update on the graph is just the positions. So like when I update the positions of the node, then I called then it makes sense to be outside of the Layern 3D mesh, I think. Just call build curve from the graph. But for each property that I change in the mesh, I think that makes sense. I think that this makes more sense than doing on the iteration each time because then like can have situations where, for example, the physics simulation stabilizes, then it doesn't make sense to rebuild the geometry. It makes more sense to make it reactive based on the states of whatever is happening, I think. So it makes more sense to call this inside of the function on the Layern 3D mesh. But it seems that it works there on the like it. But I'm gonna test first, just see if it's actually gonna update. But I think it's gonna work. Then if that works, I'm going to do the same thing for all the other properties. And once I have all the other properties, I'm going to spend a bunch of time thinking about how can I. Probably what I'm gonna do at the start is just get the cylinder and then look into the path 3D. So I might do it from the editor first. So create a CSG polygon, add the path 3D node, create a path. I do remember doing that, and it doesn't create a tube. It just creates a kind of like a square, but I might have done it wrong. But either way, I think it's probably worth it to spend some time looking at the codes for the curve 3D and the path 3D. Just see how they're calculating the path and the control nodes, control points and stuff like that. And I think that the goal is gonna be to the idea that I had was what I wrote down here. So first create simple shapes because the thing that I wanna clarify more is it's kind of confusing this relationship between points and the matrices and the vectors. Should make sense of how the position is gonna be on the visualization. Because on the visualization, the position is done with triangles. That's the thing that is very confusing. And I think based on the stuff that I was seeing here from a bunch of videos, like it seems that the way that people usually do it is by creating quads, and then the quads create manifolds or a discrete differential geometry, just basically a surface. And I was watching a bunch of these videos here, but the problem with these videos that he doesn't talk about, it's not very practical, it's very theoretical, so it's kind of hard to think about how to translate this to the actual code. Because he talks about differential equations here as well, and vectors. So I can kind of see a way, but it's not very clear on my mind. Because for me, from the previous times that I've seen the derivatives, it seems that people like just hard code the derivative, which makes sense. So basically, you get the equation, then from the equation you get the derivative, like manually, let's say, and then you just put that other equation that the derivative gives you as a function. But it is kind of confusing. It's not very clear to me how to go from the stuff that he's saying here to the actual codes. So what I want to become more familiar and to start thinking about like those experiments here is, so for example, because you're always going to be dealing with points from the vertices, and for a vector is just a difference between points. So a simple example would be to create a function that takes two vectors and takes two points and creates a vector. And this is what I mean that it gets kind of confusing because the names are already vector, but the name is vector, but it's actually a point. So this is why it's kind of difficult to think about. And also you have the triangle thing. So I need to spend some time thinking about what are the operations that I'm gonna probably use most often. Then create functions for these operations, and then build geometries based on that. So I think one of the examples is probably normals that you use all the time, but it's kind of confusing to me still. But normal is just a perpendicular vector from the surface that you're drawing, but it's kind of hard to think about it from the perspective of the point, because the point doesn't have direction, and this stuff that I'm kind of confused by. Also, the color here doesn't work. I don't know why. But the way that I'm setting the color there is just by overriding on the mesh itself. So I'm adding the color on the geometry. And you can add on the surface as well, but it has to be on the mesh. The mesh instance 3D and not the mesh that you're using inside of the mesh instance 3D, which is just a member variable of the mesh instance 3D. So mesh instance 3D has a mesh variable, member variable, which is the array mesh that I'm using there. So you set the color on the mesh instance 3D, and that makes it so that the array mesh has the color automatically. And for whatever reason, it's not working for me now. Should add directly here. So I'm probably going to spend some time, after I create the getters and setters, I'm going to spend some time thinking about like, what are the operations that I need and trying to understand the code here. So obviously just rotating to draw this sphere. The indices is another very annoying thing you should think about. I'm probably not going to create the indices for the geometries that I'm going to create here. Or I guess I can ask questions and try to clarify. It's kind of hard to think about indices. The hard part is thinking about what questions to ask. So obviously something wrong. Oh no, it worked. Nice. Okay, so I'm gonna do that for the other variables. And that's basically the stuff that I'm setting there on the codes is just the material, override material of the geometry, which inherits from mesh instance 3D. And I think you can, I haven't tried yet, but I think you can add or change the surface material for the mesh instance 3D. a surface here. I think you can set this material here from the code probably, and that should probably also change the color. But if I didn't find a way to change the color on the array mesh, the way that I think you're supposed to do it based on the documentation is just by setting the color of each point through this here and then assigning the value here. Because this is the main data structure that is going to be used to create the triangles that are going to create the mesh. And this function comes from the array mesh. So this function is similar to the other one that the other primitive mesh uses, which is just this one here, create mesh array. So I'm gonna do the member variables first, then I'll think about the geometry. But I don't know which way to go about it. I think it's all floats there. I still haven't decided which way is best to try to do it. I'm gonna put this one as an example here. So I'm gonna do on sequence here so I don't get too confused. Maybe it's better to just do a couple of them and then I finish off stream. It's kind of annoying to do this. It's very repetitive. Oh, this is gonna be an integer. And it's also very confusing. So I think I'm gonna. The problem is that I'm not really sure, but it's very likely that I'll end up using these ones. So maybe I should search for the ones that are used on the cylinder and on the tube. In the cylinder and the tube trail geometry are the closest ones. Closest ones to what I'm trying to do. A tube trail mesh. So the curve that they have on the tube trail mesh just to regulate the width of the tube and not to create the curvature on 3D. But obviously I can learn from this one and try to change this one to add the curvature. And probably what I'm gonna have to do, and the part that's kind of annoying to think about, is this part of the, like, how do you measure the change in angle based on the path of the curve? I think it has to be related to the polynomial equation to create the Bezier curve. and then the distance between points, because that's what creates the vectors. So I think it is a differential equation based on the vectors of the distance between the different points, because as like as you walk through the curve, the vector changes, and that represents the angle, represents the angle of difference of the vectors, represents the rotation you need to have on the circle to draw the curve. That is very hard to think about how to do this on code. And this is the easiest way, I think, because this way might not work as well, because it's gonna be like a whole tube. So I think probably it's probably better to copy the cylinder first, because it's a lot simpler, and then to think about from the cylinder perspective. So that's probably what I'm gonna do here. This is just a macro that gets the settings of Godot from project settings. The project settings class is the one that has all the settings. Remember, this macro allows you to get, and it's basically a tree data structure. It's an internal tree data structure because it represents a file or folder structure that contains the settings for the editor. So I think this stuff I can ignore there. It's basically gonna be this thing here. It's fairly complicated as well. So let me finish. So I'm gonna copy this stuff here. I have to see what variables that they use here. Maybe we should just copy the. I think this is probably better. It makes more sense. So I should copy the variables that I have on the cylinder. So actually, I think it makes more sense to do it from the editor first. But I think probably cylinder is gonna be like the closest one. So I copy everything from the cylinder or the variables. Then I put the setters and getters. Then I copy the code to create the geometry, and then I start changing the geometry to see what happens. I think I'm gonna spend a lot of time studying the geometry first, because I do think that the cylinder in Godot is also hollow. It doesn't have anything inside. So this is the thing that is like puzzling me the most. Is the way that I think it makes sense to make a cylinder is that you have two different circles, then you get the difference, and then on the difference you have the shape. But then how do you do that with triangles? That's the thing that I don't know. So this is the thing that is confusing me the most, I think. So that should be mesh instance 3D. So I think that if the cylinder, which probably is, I don't think that the cylinder is like a full cylinder. So if that's the case, then I think I can just spend a bunch of time studying how they do it, and then understand how the triangles are created and the other values are. And then after I really understand that, then I can start thinking about how I'm going to implement the path of the curve. Because I also think that you have values there on the cylinder that are gonna allow you to add the size, let's say. So the biggest challenge, I think, is the curvature. For the curvature, I think it's probably gonna be something related to what I was saying. It's probably something related to. There might be a way to do it without derivatives, though. That might be easier. So to begin with, without the derivative. But I do think that it makes more sense to be a derivative, because you're just basically measuring the key is because you can take any amounts of points to make up the curve. So I think this is another thing that I was thinking about. So obviously, the more points you put, the more continuous it's gonna be. Let's say, so like the higher resolution, I think. But the less or the more work you have to do. So I think that this is the reason why they create the tube trail mesh the way that they do, because but I'm not 100% sure. So the tube trail mesh is based on the extrude thing there. Not extrude is one value that I forgot. I think radius snaps. No, this is I think it's section. Yeah, it's based on the sections here. So this is what I am thinking about. I think it's like they make up a line based on how many, like this here is the number here is the amount of points that they make up the line with, and then for each point they take the difference and then they create the triangles on the outside. But I'm not 100% sure. And this is the another thing that is kind of weird, is that's like you can see that it's failing here when it doesn't have the cap, and this doesn't happen on the Blender. So I'm not 100% sure what is going on here. Is this another problem with the rotation and transformation from the world coordinates to local coordinates, stuff like that? But obviously it doesn't matter that much if you always have this on. So I think that the tube is probably going to be a higher chance that is correct, but the cylinder is easier probably. And the other thing I have to see is the CSG polygon with the path 3D. So I'm gonna try that now. So I'm gonna change to a cylinder here first, then I'm gonna try the CSG polygon. I think that those are the only two ones that are roughly what I'm thinking about doing. I don't remember which one. No, this is just another thing. I think that the cylinder and the tube are the only ones that are similar. The cylinder also has this problem where it doesn't show. It becomes transparent there. It might have to do with the winding order. So basically, because everything works, the rasterization, I think it changes the process that they use depending on the framework to draw stuff. But the main one's probably rasterization, which uses an edge function. And the edge function just gets the barycentric coordinates of a triangle, and based on that is able to determine whether or not the triangle is inside of the pixel or not. And because of that, so basically you need to draw the triangle, I think. Or the triangle is the most complex shape you can draw, because it uses this edge function to determine whether or not the triangle is inside of the pixel. And the order in which you draw the triangle, because you're sending one point at a time, so you're going to be 3 points to draw a triangle. So the order in which you send them to draw the triangle matters, because it determines whether or not the geometry is facing the camera or not. So it's back face culling or front face culling. So I think that it might have to do with this here. That's because the way that they do it there on the order, when you remove the cap here, it becomes transparent there, because it's rendering like the back. It's rendering the wrong order, I think. It might be the case. But it's hard to figure out. So I think, let me see. This is gonna just change the proportions, I think. I think the height probably changes the, yeah. So the height changes the value there. I'm probably gonna use the cylinder. I think it's better. This is gonna be easier. Radio segments is probably resolution. Yeah, radio segments is the resolution, I think. Yeah. So it's basically the way that I think they are doing. So they draw a circle and then they draw a line. They have a line which is based on the heights. And for each point, so the question is for each point, what did they do? So do they interpolate between each point and then create the surface? So they create like squares, but that wouldn't make a lot of sense either. It might make sense actually. I don't think that they are creating like a full tube because it doesn't show here, but it might be. It might be creating a full tube and then just because of the backface culling thing, the winding order of the points, it doesn't show there. Might be the case. So if that's the case, then it's kind of bad, I think, because it's worse performance, obviously, but might be, it is definitely a lot easier, I think, if that's the case. Because the way that I imagine is just basically, like I said, you get the radial segments, which is, so this is basically a quads, which is going to be two triangles, which is the simplest version, and then you just have a line. And in my case, it's going to be the curve, but it's probably the same idea. The only thing that changes is the curvature. But for each point you have inside of the curve, you just draw, you just loop over from one point to the other, and then you just draw the same stuff, the same shape. So like you have an algorithm that draws the shape in the beginning, then you just throw a loop, and then you call that algorithm to do the shape. And then I think for the 3D curve, it's just going to be something to do with the polynomial equation that builds the Bezier curve. And then you probably, when you call the function, you're just calling based on the weights of the linear interpolation of the points that creates the curve. And then from that point, I think you have to see, the question is how to get the angle, I think, from that point. But that's if you do a whole tube there. So I think I'm going to use the cylinder as an example first. The height changes the size. What is the rings though? Oh, the minimum is 4. It doesn't seem to obviously changes something, but it doesn't. So I think that the only thing that matters, like what matters the most, is just the heights. So what I'm gonna do is just copy all the variables, I think. The top radius is just so probably the first thing to do there is to simplify this, to remove this, but maybe I'll want to do this at some point, like have differences in width, but I think it's probably not gonna be, it might be useful though, I'm not really sure. Actually, this is the same shape that I'm gonna use to draw the arrow, so actually it might be useful because maybe it's possible to do like the two shapes in one, say. So like you get the position. I think it's probably useful to leave because the way that I was doing the arrow on the front end on 3JS is just by creating a cylinder and then a tube trail and then connecting the two and doing the calculation for the position. But I think I can do the same thing and just use the same geometry and then like from the points, from the size of the arrow that I have there, I just change the shape based on the vertices. So I create the function based on the parameters of the line mesh and then I change and then creates the arrow. So I think that's probably better. So mm. So I'm gonna copy, or the other thing I was gonna do here is just add the cylinder or CSG polygon 3D. And this one you can put, I think you have to put as a child of the thing, but I don't remember. It's either a path 3D or a curve 3D. And I don't remember really well this the thing. Yeah, I think you add here a bunch of points. But I don't remember how this works. Also, you can see the points there. Okay. Yeah, so okay, let's say I have this. Then on here, you go to the curve somewhere. Was it in geometry? I think it was a mode here. Not mode path. F nodes. This. Yeah, there you go. But the thing is that it doesn't create like it doesn't it creates just the thing. It creates only the square and not the circle. But I guess I can use, so this is the thing that I'm not 100% sure which way to go about it. So there's a bunch of different ways to, so one way is to do the stuff that I was talking about, like get Bezier curve, create circle, then loop over and use Bezier curve polynomial to update values of each circle. This one have to figure out how to do rotation for the circle based on direction, which is the way that Blender does it. So this way, yeah, so the other way is just look, continue to try to change Blender functions. So that's they work with Godot's data structures. Because the thing is, I think I have to. I think what I have to do is create other functions that use Godot's data structures to create this stuff. Because on the classes themselves, they don't have the functions to rotate. I think they do have functions to rotate based on quaternions, but they are functions from Node 3D, which is the base class for everything that happens on a 3D visualization. But obviously that's not what I'm trying to do because I'm trying to do the rotations based on the points, which is kind of weird. So I think it's not really the points. Like the thing is that you do the rotations on the vector, but it doesn't make sense to put the value on the point because you have to send point by point on the shader, obviously. So the value of the position is going to be just the values of the points, which are floats. But then obviously the rotation is calculated based on direction, which is vector, which is the differences between points. So I think that's for this kind of stuff, Godot doesn't have functions for it on the classes. So probably what I have to do anyway, I don't have to do it. I was doing manually on when I was trying to convert the Blender functions. But I think it makes more sense to try to create these functions to do the rotations. And I think this is the reason why I decided to do this, what I'm doing now. Because I think that's going to be better. The thing that I'm not 100% sure and I'm trying to figure out now is how to test the functions that I create to do the manipulations because I need to visually see the impact that they have on geometries. But I think I have to create these functions. It's probably better because then it's going to become more clear on my mind how to do the manipulations between the vectors and stuff like that, which is probably going to be useful outside of Bezier curves and just doing everything in general with Godot's data structure. So I think either way, if I go either way these approaches, I'm going to have to create these functions here. So it's better to create the functions and then change the functions that Blender uses to the functions that I create there. But then to be able to do that, I need to first make sure that the functions that I have are doing what I think they're supposed to be doing. So I think even if I want to do this one, it's better to do this one. But if I want to do the way that I'm doing now, to test the geometries, I have to think about what is the best way to test to see if the stuff that I'm thinking about is going to work. So I think I need to, maybe I should just do like a very simple thing first. Just create a triangle or just like a square. And then from the square, I implement the rotation, stuff like that, to try to clarify. I'll be right back. So what I was thinking about that is it might be better to just get simple geometry from to just create the square there, and then from that geometry try to create functions that's because the thing that is confusing me the most is this relationship between and it's something that is confusing since the beginning because it's not natural, I think, to think about it like this. That's like you're creating the geometry from triangles and you're passing only one point at a time. That's the thing that is kind of because if you think about, but I guess the transformations are on points as well. Like when you do the rotation on matrices, you're just manipulating point by point as well. But it's just that you do it on all points and then it moves the whole thing. So I guess that's the thing that is kind of weird because if you're, yeah, I think that's the difference. So like when you're changing the position of the geometry, for example, you're just multiplying the matrix that holds the state for that geometry with another matrix that is going to perform the rotation because the values of x, y, z values of all the points of the geometry are going to be changed by the same amount, which is just the amount that the other matrix changed. But if you're changing the nature of the geometry itself, then it's like you're performing these rotations or translations and stuff like that for specific points inside of the geometry, which then changes its shape. I think that's the part that is very hard to think about. So the part that is hard is clarifying like what exactly do I need to have here. What kind of functions do I need to have to manipulate the geometry based on the... I think that the curvature is the hardest part to think about. But I think the main paths that I'm split between are these ones. So, which probably, like I said, for the Blender, I need to do this one first. So there's only two, really. I study with Path 3D. So from this, I can just change the shape there. Also, yeah. Probably you can change the thing here, and then when you change, it changes the shape, I think. Yeah. So it's probably, like the easiest is probably to change the shape here. Like, you can just, based on the code, if I can look at the source code and then see how they do this, and then just put the algorithm to create a sphere. Should create a packet vector array for the polygon, and then you should create the tube. I think that's probably the easiest way. But probably not the better one long term. Because the thing that I don't like about, I guess I can change as well. So I'm not sure which one is the best. I'm thinking about this now instead of doing this stuff because it doesn't make sense to. So I'm going to remove. This I was gonna do anyway. Just remove everything here. This is another part that is very confusing, is the normals and the indices. Like, what is the correct way to do them? So I think one path is to like do the simplest geometry as possible and then focus, which I think is the best path, to focus on the fundamentals and do the most basic geometry first. Then figure out the normals, UVs, and vertices for that geometry, indices as well. So basically this far here, for the simplest geometry possible. Then from that one, experiment and then study what to do. The other one is just to get from CSG polygon and do the change the shape based on the other thing there. So I think I'm gonna follow this path here. But it's probably better to start with the simplest geometry possible out of this, which is probably gonna be this one. Yes, I think this makes more sense. So I'm gonna look into the, I think it's plane mesh. So in the beginning, it's probably not worth it to put getters and setters and just yeah, just put the code to create this stuff here. This is what I'm gonna do. So I'm just gonna copy this stuff. I'm gonna spend some time studying this one. Hmm. Is this even necessary there? Oh, there isn't a macro. I think it's gonna be. I just got from here. It's probably this one. So this is probably the best way. It's the longest one, but probably the best long term. Because I need to get more used to the way that Godot does the calculations and how to think about the geometries. I'm just gonna remove this and just leave the other ones. I'm gonna delete this. This seems way more complicated than it should be, probably. I guess it's because of the options that they give there. Yeah, so I think this is probably the best path, no? So start from this basic geometry, then, but I have to clarify. The thing is, I'm not 100% sure it's worth going back to the Blender stuff, too, because I know Blender. I don't know how to do it from here, but I've seen videos that's maybe it's on edit mode. Like it allows you to pull or to push edges from shapes and then curve the meshes. So this is probably the main thing that I'm very curious about on how usually this is done, because everything's drawn triangles. So this is the stuff that I'm thinking on. What kind of functions do I need to have in order to be able to do this from Godot? Maybe what I should do is just to I test a bunch of different functions and just like create random geometries. Just see what happens. So I'm gonna remove this tree. I think that this is everything that it needs here, the size. Size. So I'm gonna build and then task. Oh, this thing here. I'm just gonna remove this. Hey man, what's up? No, I'm not debugging. I'm just trying to clarify what should I do. Because I'm not. It's very confusing to me. Maybe I should watch more. I have to watch more videos, I think. And I am trying to implement something on Godot that allows me to build custom geometry from codes. So I know that the CSG polygon mesh that they have allows you to do custom geometry. I don't know to what extent but I've seen like based on tutorials that people do different kinds of stuff with that. But I'm trying to achieve more something similar to Blender. Um, but I'm not 100% sure. So in order to do that, I think I need to add functions on Godot that uses the data structures that I have, which is just basis, transform 3D, the quaternion, in order to be, so create functions that use those data structures to perform operations on the vertices, to create meshes. And based on the videos from this guy here, which I think it makes sense, the way that I think usually people do it is by creating these manifolds or discrete differential geometry. So basically you create a surface of quads, which are pairs of two triangles. Then from those quads you can basically do anything because but it has, as long as it's discrete, I think. Yeah, as long as it's discrete, then you can do anything. So I'm trying to think about what is the best way to progressively get to that point. It's kind of annoying to change the recent tutorials. I think you have to select the point to change the curve, but you can't. I know how to do it from the shortcuts. Roughly, like I know you can do it from the shortcuts, but I don't, I can't select the thing there, the handle to change. So yeah, basically the confusion is what is the best way to go about progressively implementing something that is more similar to Blender on Godot. No, thank you. Oh, I should delete this. I think I'm just gonna put this one here, just simplify, because obviously I don't care which one it is. Let's search for here. And this is kind of weird because it doesn't initialize here. That's just gonna do it like this. I think those are all the errors there. It's probably the biggest question is how to create a curved surface from quads. That's the thing that was always weird to me. Like the circle, the circle I can understand because it's just rotating around the axis and then drawing triangles. And then the more triangles you draw, the more smooth the surface seems to be because it's just approximating the shape. But I don't know how to think about the. I don't know how to think about the meshes. Like, it's like how to create a framework of functions, let's say, that allow you to create the field, let's say, of meshes from quads that represent curvature. And that's the part that is very hard to think about. Because I don't know how to go about. 'Cause I think maybe what I should do is just experiments with some functions. So I should ask ChatGPT to, for example, create or to give me a function that rotates a point, let's say, by some angle. It, the idea of rotating a point is kind of weird as well, because it only makes sense to rotate a vector, I think. So I guess, and this is a point that the guy was saying here is that like meshes are about connectivity, so which are edges. So the connection of two different points is the edge, and the mesh is about the connectivity of the points. Because obviously, if you just have random points, there's a infinite amount of ways in which you can connect them, and then the different ways will create different geometry. So I guess this is the question. Is the because the difference between the points creates the vectors, and then from the vectors you can generate. And so I guess the functions have to be at least based on a vector, which is the difference between points. And then you rotate. But then how? I guess I can start like this. So create a function that takes 2 points. So let's say, for example, that I have a quad, which is the plane there. Then you create a function that takes 2 points of the quad, creates guess the vector between them, which is gonna have the direction. Then you multiply that vector by a quaternion, and then you update the values of one of the points. And that's probably how you change the shape. But then I guess I can just do that and try and see what happens. That's probably a good start. First, I have to. I don't understand why this is so. Because in my mind, it should be a lot easier to create quads. Or you just take 4 points, obviously, and then you put there. You push the 4 points. So what is going on here? I think this is not gonna, even on the one that they have there is not gonna run this loop here. But then doesn't have any points. This is weird. I'm gonna see if there's anything, if it shows anything there. If it doesn't, I'm just gonna remove and then do it from scratch. I guess I have to ask the question as well about the normals and the indices, which was always something confusing to me as well. It's like how do the people get the indices? Is very annoying to think about. This is weird. I'm supposed to be calling this. So why is it creating a curve? So it's just creating a curve because it was cached probably, but it's not showing anything. And it makes sense that it doesn't show anything because it doesn't go on the loop there. So, which is kind of weird to me. This is kind of annoying thing as well, that every time that I change something there, I have to add the node again, but it doesn't matter that much. So maybe I should choose another shape that is easier to start. Because this is probably gonna be because of something else that happens along the line. Because there, I think it's pretty clear that this is gonna be 0 there. So there's something going on between the points that's it causes function. It's probably on the constructor. It might be on the constructor. No, it doesn't have anything. It's probably something else. I guess I can just draw the 4 points and then push and see what happens. But the thing is, if I do it like this, then I'm not 100% sure on how to do the normals and the indices. So the thing is, like, what questions should you ask to clarify this? So what I'm gonna try to do is to... So the normal, I think that conceptually I understand. It's just a perpendicular vector in relationship to the surface you have. So, but the thing that is confusing is because, like, you think about the points you draw, not the surface, when you're doing the values. So, like, what I'm thinking about, like, to create a square, what I'm thinking about doing is just creating 4 vectors that are gonna be the points. And maybe you need 6, and then the 4 is just the indices. I can get from the OpenGL tutorials as well. Pretty sure that I have there on some other file. But yeah, let me think about. Because the thing is not. I think doing the thing is not that hard to figure out how to do it. It's more about, like, clarifying conceptually how, or not conceptually, but how it works to calculate the normals on any mesh. I think the cross product between 2 vectors gives the perpendicular vector. So it's probably doing the cross product somehow. The question. So I'm gonna think about questions to ask to clarify this, and then I'm gonna collect some keywords, I think, and then research the keywords to clarify this. And I do think that this path is probably the best to go. So I should probably just do it from scratch. I was thinking about doing the plain mesh there that I have. So I studied the way, but since it's probably gonna be more complicated because they probably do something else to change the value of this, I think it makes more sense to try to do from the very beginning. So, like, one option is to get, I'm pretty sure I have code somewhere here, but I can find on the Learn OpenGL tutorial as well that to draw a simple triangle. Then all I have to do is just copy. So it's not that difficult to do, like, a square. But I think it's probably better to search for content first and, like, articles and videos, just see a systematic way to go about creating normals and normals and indices for different kinds of geometries. And then I build, like, one geometry at a time, starting from a very simple one. So I could do it like this. I can do it on a loop as well. I could try some stuff like this, but obviously it's better if I think about. But I think I'm gonna do this like through experiments and just see what happens there on the editor. But I think probably it makes more sense to search for content first, then study what usually is the best way to get to the indices and normals and UVs. Because I think that, so the way that I think it happens, or the people usually do it, is based on, I think it's probably going to be on the quads. The quad's the main one. Then from the quads, you create meshes. So I think that's based on the quad structure. You probably can implement some calculations based on the data structures that Godot has in order to get to the normal and the other stuff, which is probably going to involve the cross product of the points. So you get this distance or difference between points, you get the vectors. Once you have the vectors, you do the cross product between them, and then you get, that gives you the normal. I assume that that's how it works. And the UVs, I think, is more complicated, so I'm not 100% sure. And the indices is very annoying as well. Because I think the indices also depends on the framework you're using because of the winding order. So so yeah, I think I'm gonna stop here and I'm gonna spend some time thinking about think about search terms to clarify what way people usually do this. The biggest problem with this playlist here is that it's not very practical, at least so far. That's why I skipped a couple of them. I know. So it's talking about the math, but like the math makes sense, but translate that into the vertices is the thing that I'm having trouble with, and also thinking about the normals and the other stuff. So I need to find, I need to clarify these things first. Then once I have a better idea, probably what I'm gonna do is just create like a simple shape first, then build the functions as I create the shapes again. And I think it's probably better to create the shapes from the beginning instead of using the ones from Godot, because then it's gonna allow me to think about the functions that I'm gonna need. Then once I have a couple of functions and I build the very simple shapes, then I think what I can do is just combine the shapes that I create to try to create other shapes. And once I get to the point, then I look into I get the polynomial equation for I think I'm gonna do a quadratic Bezier curve. So I get the polynomial equation for a quadratic Bezier curve. And then I try to do the stuff that I was saying. So the main thing is curvature. So which equations should do it? The thing is that there's so many different paths to go with. That's kind of hard to choose one. Let's make it easier. Yeah, this doesn't matter, obviously, just doing true. Because I have to spend more time thinking about this, what's the best way to go about it. But I think the main thing is going to be figuring out the curvature. Yeah, so the main thing that I want to figure out and clarify is how to draw curved surfaces. And that's probably the biggest thing. Because once I figure that out, then I think you can build everything with that. So probably the main one, the beginning one is going to be quads, which is just true triangles. But I want to research on how usually people do the normals and the indices and the UVs. I think that's the stuff that I'm going to start with. So first, search for this kind of stuff. Then once I have the simple shape, then what I can do, the question is how do I create the curvature in the beginning? Like how do I build a progressive path? That's the part that's kind of hard. Because from the moment you have two quads, it's already like it's gonna come down to vertices, to vectors. So what I can try to do is just run a bunch of experiments. So like get two different quads, and then based on the points that I have, I can build functions that take the vectors from the points and calculate the angle of rotation, and then just update the values of the points based on the functions that I create. That might be the better approach, because it's kind of hard to find videos that explain this on C++. So that's probably the way that I'm gonna go about this. And if I see that it's taking a long time, then I'm probably gonna go back to converting from Blender to Godot. Because the thing that's I could look into Blender again because Blender allows you to manipulate everything as well. But I think it's gonna be it's not very, even if I can translate everything, I don't like it very much because it doesn't help me clarify like the mathematical relationships between that actually create the geometrical structures, and that's the stuff that I'm trying to clarify more. I think it's better to spend time doing that than to just make the other one, because the fundamentals is the stuff that matters the most, obviously. Like fundamentals are more likely to stay the same, and everything else is gonna change. So I think it makes a lot more sense to focus on the fundamentals and try to understand the mathematics behind creating these different shapes and then implementing them from scratch. I think that's probably better than trying to make the Bezier curve from the Blender or trying to copy the Blender. And on top of that, on the Blender stuff, you have to deal with you have to remove everything that is related to state and deal with the differences in data structures, because they use C pointers to keep track of the differences in points and other data structures. So it's like more annoying things to do. It doesn't show anything here. So yeah, I'm gonna stop streaming here and I'm going to do what I said. I'm just gonna search for, I'm gonna spend some time thinking about how can I search for, so the main thing to do now here that I'm gonna do is create a simple quad and search for what are usually the ways people calculate the normals and the indices. But obviously I can't think about good search methods now, so I'm gonna have to spend some time thinking about this. Then once I can create the quads from here, and I have the normals and the normals, indices, and UVs, I don't think I care about the tangents that much. Then I'm gonna explore on top of that, because the main thing that I want to clarify is the curves, 3D curves on surfaces, how to draw that. I think once I have that, then it becomes easier to think about the Bezier curve, because it's just gonna be creating a function that represents the curve based on the control points. Then you do a loop and you call that function based on the intervals you want, the points you have. And then it just creates a mesh from the interpolation. Either you create a mesh on the surface, which like you take the distance between the two different points, and then you create the structure on the surface based on triangles. But I think that's usually not how people do it. They just create a circle and then they just loop over the distance between points. And on the Bezier curve, if I clarify how to do the rotation of each point based on the direction of the points, what is the best way to see the difference, or see the difference in direction as the points go along the curve. Yeah, I think once you clarify that, then it becomes easier to figure out how to do it. But it's probably gonna take a very long time. So I think it's probably better to stop now and think about this stuff, because it's not gonna be very productive to just try a bunch of things here. It makes more sense to search first and study, and then come back another time to try to develop the other functions. So I'm gonna stop here. So yeah, see you next time.